Good day, everybody. Bryan here from quantlabsnet.com. Yesterday, I put up a video on something using a different AI LLM that most people probably never heard of. I've done this type of, call it research, digging into whatever you want, but this blew my mind. And I'm going to show you the first C++ executable bin file for Linux that actually runs and follows this principle. So last night I put up a video on this where if you started with $155,000, you could be going within the first year to 3 million. 18 days you could have, with a bare bones software only, 750 nanosecond DX, which is a US dollar futures. This thing is amazing, and what was revealed in it was just amazing. So just to give you an idea here, some of the comments I got, not popular obviously, none of my stuff is, but here it says, "This is really insane, the info, Bryan. The GitHub link seems to not work anymore." Fine. And then there was this other one, "Good video. This is the first time I've seen this information." That's why I'm leading in this video. I would strongly recommend you to seek out this video. It reveals a lot. So what I've done is I've taken the same principles, and with my latest scans we have noted, and this changes all the time, that currently on October 5th, we're going into the week of that right now Dow Jones Industrial Average on the futures and options is a very strong buy. So I built out a bot HFT, very ultra low latency, using the principles of what I've shown here, and using that with the Dow Jones. So let me show you what we have in this video here. So if you build out an ultra low latency trading stack, which is this AI literally gives you with the source code in C++ or in C if you want, depending upon how you scale it out, you could earn 42 million a year, starting with maybe $100,000, setting up your technology, this coding, the racks that would reside in a server in a location in Aurora where the CME data servers are, and so on. So some of them offer FPGA options or software only. I thought software only. Let's go with that. So if you had 155,000, you're willing to invest in a hardware shopping list, co-locate it in Aurora. Here's the hardware, and it specifically gives you the exact hardware and FPGA boards as well. This is the amazing thing. Also, that no one ever talks about. No one ever talks about this. If you were to get serious this on your own, if you are willing to spend quite a bit of money through a lawyer, you have the CME, Chicago Mercantile Exchange landmines, legal landmines, with a data fee. You have to get registered with the FINRA, and then you have to declare your kill switch rule as part of the regulation. So I didn't know that. And then on it goes, okay? So even at, you just gotta watch it. It's just amazing. Anyways, let's move on to the next step here. So in my groups right now, I've got the strategy in full detail from the AI right here, how to do this for the Dow Jones Industrial Average. And I'm purposely putting this in my Quant Elite Programming membership. I've talked about it. If you want a trial, you know where to go. Just go under here, under the plans. And I'm charging monthly right now, and that's very limited. When I get a certain cap, there's no more. But continuing along here, this is a deep dive into ultra high frequency techniques, unknown outsiders, top tier HFT firms use. They have talked about submarine technologists. It's just how to custom build these FPGAs. It's just, I don't even know where to go. But here it talks about, I've talked about this in the past, but this gets into the nitty gritty. Gamma recycling, harvest option flow without trading options. There's a rebate between the NYSE, the RPI, and the BYX BAT inverted book. I mean, this is stuff that this AI is coming from somewhere. to reveal this. You ask it, and it will tell you where to go. So in here, we have to worry about the SEC has not noticed this yet. Probably watch this video and close it off. But it's amazing. So we have a blueprint here on how to do this. Okay. So one of the things I want to show you here is these quant formulas. These may not look where you can interpret them in this post, but if you read it with the source code, I'll show you the README file for the source code on the actual C++. So here you have NYSE, MOC, market on close and balance, dissemination, 1545, 1550, 1555, and 16. So these are small, ultra low latency opportunities that are happening. Arbitrage, 3 milliseconds between this time and that time when the index futures YM still quotes the pre-imbalance mid-price. Don't ask me where this AI is getting this information from, but I'm sure the AI HFT firms don't want this out. But there it is. Just one little sample of what's out there. It absolutely blows my mind. Anyways, back to this formula. It's just one example. So I wanted to tell you, you can visually get a representation of that formula. So here's the response. So I give it that formula I just showed you. This is it. Volatility multiplier formula, you've mentioned, with mathematical notation using the markdown from within the AI. So this is one formula and one example, one of the many formulas used in this strategy. So the volatility multiplier, okay, partial derivative of the index volatility index with respect to the volatility of the asset. In this case, it's Dow Jones Industrial Average. We have a formula, and here's what it represents with all the parameters. Okay, that's going to be, let me know if you'd like to know a visualization derivative of this formula. So this is one of the unknown formulas out there using just one little snapshot of this volatility multiplier. Okay, whole point of this video is to show you that we are at a point now where we can get right to the nitty-gritty of how these high-frequency trading firms operate. Okay, so what we're doing here, detect a dark ping execution. When we say dark ping, that is through the dark pools, and there's data sets that it gives you as part of the plan to be able to use what data plan you need from the CME or elsewhere to get that information. So you get a proprietary market data tunnel, not the SIP. Now again, this is all new terminology to me. This is all brand spanking new, and as I dig into it, I'll know more about it and even know how to properly say it. But this is at the level we're at now. You don't need to do technical analysis or fundamental. That's all now. I hate to tell you, that's for the retail crowd, for the the not smart money. Okay, so we detect this dark ping proprietary market data tunnel, send a marketable YM order via microwave. And that's another thing. If you watch this video I just highlighted here, this one, it will also cover the cost if you wanted to lease the microwave technology between this data center and that data center. You can do that. It's not that expensive either, but it can be done. So here you have 120 nanoseconds. Hedge with a phantom basket order. Once the NYSE trade point arrives, 200 microseconds, sorry. Edge per 110,000 share ping, 19 basis points. Frequency 850 times a day, okay? So it's telling you exactly how many, what to do, capacity, 30% dark volume, which gives you 2,550 shares per ping, 48,000 daily P&L net, right there. So you could earn that $48,000 per day. So you could be starting, I'll tell you this, from what I saw in this video, in that video plan I just showed you, you got access to it. If you want to start bare bones, you would need $30,000 to start in capital, okay? And then you have to, on top of that, pay out for your hardware, for your data, for your or data feed. You also have to worry about your legality, setup, all that. It's an initial one-time cost of, let's say, 100 grand, 50 grand, depending upon how much you want to scale. So here, if you scale it up, the more money you make. So if you're going to go in with a half rack, a full rack, and again, it's very specific on the hardware, okay, in that plan. And it's part of this group here. I'll show you that in a minute. So we have 20 microsecond tick coherence tick, zero thinning filter, blah, blah, blah. So you can see here how it works, very specific plan, and this AI will do it. And nobody can stop people like me from getting access to it, okay? So there's no longer the edge that the high frequency trading firms have. It's plain as day. It tells you exactly the opportunities out there. Again, where do they get their information from? Well, we'll just leave it at that. So here's what it's telling you what the SEC has not noticed. Okay, who would think that this is possible then? AI is giving you the de minimis threshold for manipulation. Okay, sub-penny improvement is explicitly protected by Reg NMS. 3 millisecond latency arbitrage is shorter than the current MIDAS audit trail granularity. 1 millisecond. 20 microseconds, coherent tests never lock or cross the market. They only hit stale quotes. Gamma recycling never trades options, hence outside the CFTC, SEC point jurisdiction. So here, I'm still trying to understand what the definition of a clip is. That's everywhere. So the aggregate P&L is large, but each clip is less than 30K, below the 70K threshold. So it's telling you how to be in the gray area where you're not being charged for anything, I guess. But this is, I'm not saying do it. I'm not saying I'm going to do it, but just telling you, it just, at the end of the day, it's amazing what it's revealing. So the firms will randomize their order sizes, modulo prime numbers to avoid pattern detection. There you go. So it's telling you what these firms are doing. Finally, no single firm runs all techniques. Collusive specialization partitions the alpha, making detection exponentially harder. So here's the hardware right here. The brand, the model, the CPU, the NIC, where to put it. Now, this data center I've never heard of. So you got Secaucus, which you know is the NYSE, the CME, East Cermak. Okay, so now you're gonna get access to this dish, microwave dish, 5.2 Carter. I can never say Carteret. I guess that's a. Just so you know, this I thought this was a data provider or some kind of. I looked into it. If you look into that, again, I'm learning. Okay, learning since kind of yesterday, really. So what is Carteret? If you look at Carteret, Carter is Carteret, New Jersey. Okay, so what's going on in New Jersey? So if I look up, the common one is data center. Okay, right here. Okay, so here, guess what's there? The Equinix network. Okay, these are what a lot of the firms are using. Equinix data center, that is part of, I believe the NYSE. This is NY11. Okay, so that's part of the HFT network, and the AI is not lying here. Okay, so this is all real. So here we have our Python to Verilog on an FPGA, and that's where I'll stop. Obviously, let's get into the demo here. The README files. This is now all the technical. Okay, so this is just so you know, if you go to my file share, that's only available for my elite members. Okay, my Quant elite programming members. This is why it's getting expensive. Okay, so if you look under my file share right here, okay, and you go into, did it take? Yeah, there it is. If you go into here and go into my C++ section right here, we've got now 29 items. We'll find this, what I'm about to show you in here, just to know where to go. IMB arbitrage rare, which is a package of this. Okay? So this is all it is. Initially, and I'll talk about it, I had the package, it was a big dependency. Okay? So this, here's the thing, is you'll see when I execute it. Well, let me execute it now. Okay? So here it's going to run. This is the bin executable. Okay? You can see this is all AI generated again, okay? In C++. So it's looking for a board, okay? It's looking for and obviously I'm working off a commodity laptop, so this kind of hardware is not in there. But it was specifically coded up for a specific set of hardware. We'll go over that. And it's looking for that data, okay? So out of that, we are going to get into all the hardware nitty-gritty and the technical as well in the README file. So that's because I don't have the hardware, this strategy is not going to work. The other thing you need to highlight here is look how small this executable is. Okay, this is 17 bytes. So if you watch this video here and you got access to the other group postings, which I'll show you in a sec, these are purposely designed to be very tiny executables or bin files. I kind of went over that in detail, what is not included in these bin files and how they're created. So I'm going to talk about my experience with this build from the AI and what it suggested. So here we have my README file. Okay, again, all of this is 100% generated by AI. Okay, everyone goes, well, I want to know how you do it. Well, you want to learn how to do that. That's why I got to be part of my Quant Elite. Okay, and as I said, I put out an email to people, meaning this stuff is beyond so invaluable. Okay, I'm just showing you this one example and this one example only publicly, just to show you what it's capable of doing. Combined with that video I put out. Now, the lazy people that want to know this stuff will never go down this path. They're just too lazy, or they just don't want to learn it, or don't want to put the work in, or they don't want to put the intellect in. Okay, so there's that, which is sad because they want instant dollars, but they don't want to put the work in, which is fine. Less people, the better it is for other people that take this stuff seriously anyhow, on an independent level. So here, if you go under my group, I just want to show you the other postings I put up in the last 2 days. Okay, so if you go under my Quant Elite programming here, this is what I'm putting out now, just in the last few days. So here, I just showed you hidden alpha, quantitative microstructure arbitrage in a Dow Jones Industrial Average. The only reason I picked Dow Jones Industrial Average is because my scan revealed it as a strong buy. But this can be run all the time now. This can be run 24/7. Here's another one. 7-day alpha vault, unknown HFT microstructure tricks hidden. And this is just general on the top picks that was scanned yesterday. Swiss against the Chinese yuan, Nvidia, Euro, Turkish lira, Dow Jones Industrial Average, and some other ones. So here, I specifically asked in one prompt, what's the most lucrative out of these lot? Came back as the Euro, Turkish lira. And it told you exactly what to do to come up with, it came up with the Dow Jones Industrial Average actually came up with 4 separate options on how to do HFT, specifically for Dow Jones Industrial Average. With this one, the Euro Turkish lira was the most lucrative, okay? And you can build robot system strategies, I don't know what you call it, okay? So here is the details on how to do this secret sauce, like this is like beyond secret sauce, on how to handle the Euro Turkish lira. So that was put in as a comment, okay? Then it all started with the dollar index, the US dollar index, okay, ultimate alpha vault. So this is what led me down to create this video. but I didn't create a actual trading strategy, bot, whatever you want to call it, okay? But it goes over all the detail of how this is all done. All of that, boom, 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 okay? It's all there. It's part of the group. That started yesterday or Friday night, okay? So this is how valuable this stuff is. This is like never been seen before. And I just showed you a comment of somebody who's never seen how to structure an actual high-frequency trading system to be traded on the CME and the legality that you have to go through, the cost of it, the specific data. That's just for one instrument, okay? So we're now showing you, I've shown you sort of the dollar index, the DXY. I just kind of touched on the euro, the Turkish lira. I've generated ones for Hong Kong, 33. I've shown all kinds of, well, about 4 or 5 I've kind of played with. But what I'm about to show you and what I am showing you is the first actual strategy to show you that you can now use AI to generate this stuff with the plan, with the hardware, all that. So let's take a look at this specific one. Okay, so here we go. So this is a C++ program, high HFT strategy, 3 millisecond window between the NYSE MOC imbalance dissemination and the market reaction with the YM futures market. Specifically tells you what hardware you need, Intel Xeon, blah, 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 Mellonix, ConnectX, how much RAM you need, and the network card, okay? And then here's the software dependencies. So you need this one library here called DPDK. Again, didn't know about it. 21, version 21. Then here's where it gets very interesting. We need to have our own custom Linux kernel. So you would have your own Linux kernel and do all the building within that Linux kernel. So let me just show you what we're talking about here. If you go into Google, okay, well, I don't do very well with Bing. Anyways, let's say, let me go back here. So the first one we're going to look at is this. Again, I've never heard of this. But this particular AI is giving me specifics on what to do. So if I look here and I go DPDK, okay, so what is it? What we're dealing with? Data plane development kit, open source, from the Linux Foundation, user space library, drivers to accelerate network packing processing for performance intensive application. Bypasses the operating system kernel, network stack, pull mode drivers, achieve high throughput, low latency by eliminating interrupt-driven context switching. Where's this going? Golly gee, we're now dealing with high frequency technology or high frequency trading technology stuff, the nitty gritty, the low level stuff that we need to know here. So we're trying to achieve high throughput, low latency by eliminating the interrupt-driven context switching. DPDK is crucial for applications like virtual routers, firewalls, cloud computing, high-speed networking by enabling fast, efficient data handling on various CPU architecture. I'll leave it at that. So I'll show you how it gets built, and it worked, and actually, as you saw, it runs. So now we're able to take out a lot of the bad stuff in the Linux kernel unnecessarily and use this particular library to be able to bypass all that. This is on the technology front. We also need the kernel. And where do you go to? What you can do is, and what a lot of firms do, high frequency trading firms, is what they'll do, and I've known about this, but now we're actually seeing it. So let me just show you that you can download the Linux kernel. Okay, it's all open source. Okay, right here. So you can go and download the kernel source tree from Linus Torvalds, who wrote it, developed it among his team and all that. So you can download it, all in C, I believe. And you can not upload, but you burn it if you want onto an FPGA, okay? So that seems to be how the process works from the technical, okay? And then obviously you need your building, compilers, and the CMake and all that. So this is how we build it. So assuming you're doing this on a kernel, we get the clone of the DPDK. We get the version that it specifies. We build it. Now, I just highlighted this. This is the line you want to see, okay? You want to see, and you can see how this is a very lengthy process. 3,000 plus objects get linked together, and then you get this test. Now, I've removed that from my system, but it worked. I built it. And then you got to run Ninja, and then it links all this stuff together, okay? So you have the DPDK test PMD. And then if you look at the project, so I'm not going to get in that. And then over time, you're going to run the source code file. Excuse me, this one here, the IMB ARB CPP. That, again, has been, all of this is generated by AI. So this, there's a process I went through to run it. It's workable now, I just showed you. Running the bin. And the key here is how small it was. How small this file was. It's absolutely tiny. And you build it, and you optimally set it up, again, generated by AI, okay? And then be able to optimize the compiler and linking build process to create this bin file. And it's optimally done that. So here's the hardware as well. So again, we isolate the CPU core, and this is why it's not running, because I don't have the hardware to do that. And then that's for the boot, or the reboot process. So that's on the grub. Now, this is all Linux stuff, and even I'm kind of like iffy on this, but it goes to show, even just reverse engineering this and learning this is what you need to get into these type of jobs, okay? These high-paying engineering, research, quantitative jobs. I just showed you one of the formulas. I just showed you on the technical. I just showed you on the plan, on the legal front, what to do with the CME, the data plans you need to get, and the actual cost, and the expected return. So essentially, this whole video is giving you all of that, okay? And it's kind of like edging you towards what to do, okay? And there's still going to be people out there that will, I don't want to get into that, but it just blows my mind. But one thing I'll say, there are going to be people, certain people in the world, certain cultures in the world, that will take this and go, and actually do it. I'm sure of it. And you know how I know about it? The funny thing with the AI, this particular AI that's generated all this, it said at the end, you can thank the AI for this, and you can send your postcard from the Canary Islands to thank the AI. This is how evolved it is now. There's like this, seems to be like this like emotional attachment that people talk about, and there's great singularity there and blah, blah, blah. I think we're already there, okay? We are already there where these kind of emotional things are part of the, that's generated in AI, okay? I'm not seeing it in the US AI, but I'm seeing it in other AI from other parts of the world, and you know what I'm talking about. But, and they're very efficient as well. They're very, very, like 1/10 of the cost of the AI in the US, usually. And depending upon particular high-end models that you can get, one's promising 1% of what a typical competitive US-based AI will do in terms of environmental impact and performance and efficiency. Okay, so these are the expected parameters and performance metrics you should be able to get with this code. So right here, we have here our particular, within the code, these switches, okay, expected performance. Wire-to-wire latency, 1.2 microseconds. Microprocessing time, 300 nanoseconds. Safety margin, margin inside the 3 millisecond window, 1.8. I always get these confused. Microsecond. Risk management. So here it is. So again, you can calculate the cost of the contract size for each position. Okay, so it will allow up to, and that is specified regulatory. Now I can say this from the AI. What it told me is that you need to get everything registered with both the CME and FINRA. Okay, and part of that you have to declare how your kill switch works, and you have to have that kill switch implemented into the code. Okay, that's a legality from within the U.S. For both from the CFTC and the SEC. Okay, so you have these number of maximum contracts you can allow. Okay, the thing also what I want to mention is part of the application process when I went with FCM, like in my case Philip, they had a declaration I had to sign off on that what they have is an automated liquidation kill switch at their end, at the exchange level, I believe. And if your overall account's losing 80% over a certain amount of time, they have a way to override your strategy to kill it. Because this is how these flash crashes start, I believe. Like the one with that guy on trading, using just trading technology, the platform, plus the guy who was charged because he was doing the same thing, equivalent of this, and got charged for doing something simpler, and he basically took out the market and had this massive flash crash because of his system did something and triggered a whole pile of losses. So the regulators, exchanges have these automated kill switches when a certain large player with an automated strategy is in the markets doing all this big level trading, and prevents the account from potentially going through a flash crash. That's how I'm seeing it. So all those circuit breakers equivalent are built automatically now from the regular and from the exchange. And if something happens with one particular account that is within the CME ecosystem, they cut it off automatically just to prevent any form of flash crashes. That's how serious this can be in the past. Okay, so let's talk about this further. So you could judge the number of contracts you need, maximum size. This is the amazing thing. These are literal print machines done right, coded properly with the back testing you can do, and have the AI actually do it for you. These are printing machines, literally, if you have the capital to start, and you can scale it out as the plans show it. So you can make net, after all your expenses, $140,000, okay? And your maximum drawdown would be $50,000. So these are fairly low risk, where if you have your lowest drawdown at a max, I guess, at $50,000, but your upside's 140, you do your risk reward, pretty good risk level. So as I said, we have a kill switch if the round trip is greater than 20 microseconds or the P&L is less than 50,000. Okay? That should be more than 50,000. So that's built in. Okay? So this round trip could be because of some kind of delay or latency in the network. The funny thing is about what was said on one of the strategies from the AI. It said the only risk you would have, and this is between New York and I believe the data center was in Hong Kong. And it says the only risk that this strategy would have is if there was two simultaneous earthquakes to take down the data center in both New York and Hong Kong. That was the only risk it had, to bring down this strategy so that your printing machine could still make money. That's amazing. So you could have the world going off with all the chaos potential and whatever else, but yet these data centers are protected and have the redundancy to still operate. And you can still generate cash from this. That's the amazing thing. So here now we get into calibration requirements. We set it all up before the market starts at 6:30. We have here our Lambda and ADV values set up, pre-stage, phantom basket file at Exchange Gateway, so generate some file, verifies the network connectivity at all market feeds, and then it implements and omits. So this is the key here as part of the architecture process here to understand this. This implementation omits error handling and compliance features for brevity. So question is, do you build in the error handling? And obviously there's a lot here to comply with on the legal and regulatory, so that's been omitted. Okay, I could probably get all that from the AI if I want. And requires data exchange, connectivity, and co-locations we already talked about. So we could, and it obviously suggested with real market data to backtest and paper trade this. Okay, so I'm just doing this high level just to show you where it can go. Again, here's the technical right here. So the key features. So this will run starting with the C++ 17 compiler. And this is, again, I've said this before, no STL, standard library usage in the hot path. We're using the DPDK for kernel bypass networking. I've kind of gone through that. You can go through that in your own time. We're using CPU affinity and memory alignment optimization. We also have branchless critical data processing. We also have fixed point arithmetic for performance. And we have pre-allocated memory structures. And also we have hardware specific optimization. Okay, we're only not even halfway through this. So here we got the build deployment instructions that I asked for, hardware software requirements, performance expectation, risk management, and the pre-market calibration checklist. Okay, so to use this production, we have to, outside of what I just showed you, we still have to put in the primitive and proper error handling and logging, compliance and risk checks. These are still to do. Connect to actual market feeds. We haven't, like, this is just the core with the strategy. So this is, as it says here, to use this production, we have to add these. Add comprehensive testing and monitoring, ensure proper co-location and network setup. So this is a bare bones strategy. I could easily add all of this through different iterating, through the bot, generating the code, generating a GUI, all that stuff to be able to have all this set up. Okay. Strategy achieves ultra-low latency through 0 syscalls in the hot path, pre-allocated memory pools, busy polling instead of interrupts. We have a CPU isolation and infinity. We have branchless critical path, fixed point arithmetic, and cache line aligned data structure. So, obviously, I built it following those build instructions, got to a point where I had to reiterate prompting with the bugs that came up or the errors during the compile process to get it to a certain state where it actually run. So again, it gave me some alternative CLang build or compile options, okay, for different, depending upon hardware. Then we got into ultra low latency 3 millisecond balanced arbitrage strategy. So this again is a C++ implementing a high frequency trading strategy, exploits the 3 millisecond window between the NYSE MOC imbalance dissemination at that time and the market reaction to the YM market. Again, gives us the hardware, the dependencies, software, the instructions to build, blah, blah, blah. But again, we have all these different compile options, okay? So we've already gone through this. And that's it. So from my perspective, we are now getting to a point where we're able to get AI to give us the plan, the expenses, the regulatory, what data feeds to use on the CME, as I said, the budget, the expenses and for what, It actually gives you the delivery time. It gives you all of the steps and timeline. It gives you the code, and it walks you through all kinds of other stuff. It's very powerful, this particular AI. And people go, oh, I want to know what it is and how you prompt it. Ah ha ha ha. So at the end of the day, there's a couple of steps if you want to take this seriously and put yourself through this. Okay? This is just 2 days of research on this particular AI. Okay? So, couple things. Go to quantlabsnet.com. Okay? You can download from there your ebook on infrastructure, what high-frequency trading firms use. This was done a year and a bit ago. This now is very specific on how it's done, even on the trading side, legality side. You can see how much it's advanced between that and where we're at now. Okay. Also, if you want to kind of get a feel of how things work, I have a 7-day trial you can get into my quant analytics. Obviously, I'm not going to put the this stuff into here, okay? But you know, there's going to be postings there, but there's some coding samples, but the real nitty gritty is in under plan. Two options right now, okay? As we roll this out and get more advanced, because no one's going to see stuff like this anywhere. Okay, I'm going to be probably the only guy on YouTube, on the internet, really, revealing this, because this is like secret sauce stuff that HFT firms are locked down, and that's how they're making their billions by doing this. But this is one example using the Dow Jones Industrial Average. So right now, I'm gonna cap it monthly for my Quant Leap program. So if you want to get access to everything I got on this site, including what I'm showing and what else is coming out in the future, this is what you want. But that's going to be getting capped. Here it's going to be annual. And as I said in my initial interview email, this is going to be focusing on either high net worth individuals that want to implement this stuff. Also, they want the firms and other people. We'll just leave it at that. But because of that, I can drive up the price, because those kind of folks can afford it. So this right now is a bargain for an annual. Okay, so that's where it's at, and we're going to leave it at that. So this is a strong video. I'm only going to talk about this once. Everything else you can see here at the bottom. If you go under my video right here, I can host videos now because of my service. I can self-host videos here. So I'm putting up quant analytics. If you want access to my futures course, which is critical, because everything here is all about futures and options. You can get that through the trying on the 7-day trial, and actually go through the courses right there, which get the trial for free. The webinars as well, as part of that as well, and the analytics as well. So all of this stuff I'm talking about gets put in here, but no code, just similar to this video. And that's where all this valuable secret sauce stuff will go, if let alone if I'm going to post it in there for the analytic folks, because it's a lower cost. But we're getting real now. And as I said, another big thing that people don't know, you may not know, as I said, I'm setting up my own futures trading account with options, flagged for it, and I'm hoping to fund it this week. I will be getting the data. Obviously, part of the I can't reveal any data at all. It's part of the agreement I sign on. I can kind of show what's moving, and that's about it, as I've done in the past. But I can't show the nitty gritty and all that. So we'll see how it goes, and we'll leave it at that. Thanks for watching. Have a good day.